Good morning students, welcome back. In this video we are going to try the numerical sections of chapter 10 physics. Now see, first 5 video is totally based on the theory section. Theory section. So you have to find the answer from that theory videos. Okay, now first one, the explanation is given in the video where answer is yes. You have to find out why it is yes. Try in a homework. Now next 5 sums or questions are all of theory based question, where for example they are fill-ups, true or false, or give reason. So you have to find or try to find the answer from the theory video. Yeah, sure, if you are confused or not getting the answer, you can ask a question surely. Now see, for the fifth one, you have to find the force and the pressure for the given condition. Now where they have given the mass and diameter. So mass of is in kg, diameter is in centimeter, so I'm converted into a meter. Now radius, if diameter is given, so divide by 2 I will get my radius. Area is pi r square. I know my r, just multiply and get the area. Now you know actually F is equal to ma, but here the object is falling freely, so mg. So 50 into 9.8 you will get your force. Now for the pressure, you know the formula is F upon A. You have already calculated F from here. A is you have calculated here. Just place the value, you will get your the pressure on horizontal floor. It is easy. Okay. Now see the next one. It is also a very easy kind of sum, because you have to use just a simple formula where they have given the density of one material 13.6 into 10 raised to 3 meter per cube, where height is given of a liquid of 0.76 meter. Density of another material is given. Height second you have to find, where g is given 9.8 meter per second square. So here you know the condition that for the equilibrium both will be the same. So I will write rho 1 h1 g1 is equal to rho 2 h2 g2. G1 G2 will be the same value because G value is throughout same, you are taking a constant. So H1 you will get your rho 1 H1 upon rho 2 G is cancelled out. Place the value and find the answer for H2. Okay, it's very simple. Second question, I want you read to understand the question carefully. The answer is yes. Who and how and why. All the condition you should know. Here, see, they have given you Pascal, 10 raised to 9 Pascal. They have given you D in kilometers. So first of all, convert it into a meters. Rho is given, density is given, and G value is the constant. So depth is given. So you know your depth is rho dg. Rho d and g. Multiply this, you will get your other depth value on the top of the oil. Okay. Remember the maximum stress, okay, of the structure is 10 raised to 9 Pascal, that is horizontal. See, 10 raised to 9 2.9 into 10 raised to 7 Pascal. Okay, that is on the top of, and here you have to find for the given condition. Just apply a simple formula, you will get your answer. Now for the next one, it's the same thing. You have to find that for force and a pressure. They have provided you mass, A is given to you, so F and first F is equal to mg. Actually should MA, A is equal to G here. So multiply it, you will get your, now for the pressure, just divide that your force by area, you will get your pressure in Pascal. Okay. Now for the next one, I want you to read the question carefully and understand it, where they have given you height of one object and another condition such that is in centimeter. First of all, convert it into a meter. I am considering as P0 is atmosphere, ρ1 for the spirit and ρ2 for the water. That is for spirit and water, two level heights are there. The pressure at P, similarly at D, you will also have the different pressure because of that. So pressure is formula is simple, P0 H H1 ρ1 G. That's considering I'm equation A, and for at the point D I'm considering as P0 H2 ρ2 G in will be equation B. But here they have given that these two are in equilibrium condition. So ρ1 upon ρ2 is equal to H1 upon H2 will give you the specific gravity. Here you are finding the specific gravity. So that's why I am using this condition that both are in equilibrium condition. Otherwise you have to know, you should know the values of H1, H2, ρ1, ρ2, all the values should be known, and then also it will not get that it is equilibrium condition or not. In the next question, 10th one, see they have given you two different heights. First of all, I'm converting into a centimeter. I'm adding this plus 50 because the base is given, which is already there. So three different densities given for the water, spirit and other one which you have to find. Here you know the formula is for the liquid is pressure is H rho G is equal to H into 13.6, that is given, and G is constant, but I can write for two different terms for two different conditions, H1 and H2, ρ1 and ρ2, and G will be the constant. G I am taking on constant, keeping the value of rho and H1 and H2 and ρ1 and ρ2. You will consider your P0 is equal to 3 rho G. After G value is constant, so you can keep it, or otherwise keep it as same. And now the condition is also such that they have given you that 3.6 Hg is equal to your 3G. So Gg will cancel out. So you will get your value as H, which you have to find is nearly almost 0.22. Okay. The difference level between mercury of two level of arms is this much, which you have calculated. That's you want to find the answers. Okay, easy. Now next one is also totally theory based question. The answer is no in both 11 and 12. I want you to find the answer from theory section video part. Why? You have to find the answer why it is no. Reason you have to find from the theory section. Now next one, see here they have given you a pressure in Pascal. They've provided you L R and D, that is length, radius and diameter. Diameter means if we have calculated from the given radius, you have to find the pressure and the Rowland's number. So here the glycerin flow density is given to you is 4 into 10 raised to 3 meter per second square. M is given to you and density is also. Now you know the values for the viscosity is also given here in the question. So directly a simple formula apply, that your V is equal to M upon rho, that is volume is equal to mass upon density. You will get your volume. Okay, you will get your volume. Now just use the given condition. For the given condition formula, V is equal to pi p r raised to 4 8 n L upon. Okay, so just place all this value. You know the value of V, you know it is n is constant given, L is given, pi value is constant, R you have calculated earlier. So just place all this value here. What I did, I make as P as a subject from here, and I have just rewrite the equation after rearrangement, and I can solve my sum. Now other thing we have to find is the Rowland number. So directly again you can apply the formula for PV is equal to pi d into viscosity eta. All this value is in known. I want you to place the value here and find the answer. Now I want you to read and understand the question carefully, that in the given video they have given V1 and V2, and area and density is also given, area and density is given. Now here according to the given condition you can use the Bernoulli theorem, that is your Pi plus half rho Vi is equal to Vi square is equal to constant. So I can write my P1 half rho V1 square plus is equal to P2 half P2 plus half rho V2 square. So P2 minus P1, from this arrangement I will get my P2 minus P1 is equal to half rho V1 square minus V2 square. Now lift on the wings is such that you can write your P2 minus P1 A, that is equal to half into rho P V1 square minus V2 square, because these two sum are same. I'm just multiplying on A on both the side. Okay, from here multiplying the A on both the side. Now it's very easy for you to find the sum answers just by applying this, placing this all value here and find the answer. What you will get, that's your final result. Now see, next one, here you have to find the diameter. You have to draw the diagram, a figure based on the theory part you have already learned. You have already done in previous lecture. Okay, here now see the next one. Again understand the question properly, that they've given you area. So centimeter is given. First of all I'm converting into meter. They've given you n number. Diameter is given in mm, so first I am converting into m, then I am finding the radius. From that, area is pi r square because the shape is given, r you know, find it. There are 40 holes, so n into a, so area into your 40. Apply the form, just place the values, you will get your area. Now for that, next they've given that is 15 meter per minute, so I'm converting into meter per second. How you will do? Just divided by 60. Now speed of the ejection of the liquid through a tube. I'm considering as V2. Using the condition for the liquid in the given condition that my A1 V1 is equal to A2 V2, I can find my V2, and this all value A1 V1 and A2 you have already calculated here. Just place it here and you will get your answer in meter per second. See for the next one. It's a simple and easy thing that here they have given you work done. A length is given in centimeters. First of all, convert it into meter. A total length is equal to 2L because it is your 2 times. So 2L you will get your total length. Surface tension you have to find here. So for surface tension you have to find here. So formula is S upon F upon 2L, that is 1.5 into 10 raised to minus 2 and divided by 0.6. You will do just place this value, solve this equation values, and you will get your surface tension in Newton per meter. Okay, now I want this two 18 and 19 number to be solved in homework. Try to solve. Okay, hint I'm providing you that for 18 number you have to find the surface tension. So formula you will use W upon 2L, surface tension, and here you have to find the pressure. Formula you will use in 19 is 2S upon R plus P0. They have given you the value of work done. If it's not that thing, they have given you the force and a distance which you can find, or they might have give you the energy. So if it's the twisted, you have to solve in that manner. Now see the next one. Here the excessive pressure is inside the bubble is given. You have to understand the question first properly. They have given the bubble where have a pressure inside and outside. The pressure of air bubble inside is given to you. Excessive pressure is given to you. A show radius is provided to you. Moreover, surface tension is given to you. So relative density is also provided in the question. Density of the solution is given to you. Radius is given to you. Height of the liquid at which in the container it is filled. Till what it is filled, it is provided to you. 1 atmospheric value is constant. G value is constant. Here just you have to find the first. Your excessive pressure is 4S by R. Surface tension value is provided to you. R you know, just apply the and you will get your excess. Now P dash is equal to your 2S upon R. Similarly find this. After that what you have to do, you have to find the total pressure. So that will be your atmospheric pressure plus H rho G, that is due to liquid, and the pressure which you have found it earlier. So place all this value, you will get the total pressure in the equation after solving this terms. So you will get your pressure. The next one is also a similarly kind of equation, where you have to find the force. So hint here, I'm giving you that you have to use your P1 and P2 is equal to H rho 1 G and H2 rho G. You can make that P1 and P2 constant, then solve the sum. It will be easier. or you can see you can do that your delta p, because you don't know it's same or not, so find delta p. Okay, after that you know that your delta p value, when it is multiplied by the given q, you will get your force. So it's a very simple sum. I want you to try to yourself. Okay.